Hey everyone, welcome to episode 1 of Save Our Science. What we're going to focus on today is having a look at chromatography. So we'll have a look at those key facts first of all, find out a little bit about what chromatography is, how it works, and then we'll have a look at an exam question they could ask you and how we should answer it. So when it comes to actually carrying out chromatography, you probably need to know about 3 different ways we could do this. So the first one is the one you've almost certainly done at school, which is good old paper chromatography. So where we're talking about paper chromatography, then our stationary phase, the one that doesn't move, is the bit of filter paper, and the mobile phase, the one that does move, is going to be the water that's going to be in our beaker. So what we actually need to do then is set up our chromatography, and you do need to know how to do this. So what we're actually going to do is, first of all, on our bit of filter paper here, then we're going to measure up from the bottom about 2 centimeters, and then using a pencil, very important we use a pencil here, then you're going to put a little horizontal line 2 centimeters up from the bottom of your filter paper. Okay, so what we end up with is a little pencil line 2 centimeters up from the bottom there. Now that's going to be our starting point. So what's going to happen is we're then going to get a bit of our sample. So we're going to pick our pen, whichever we want to look at, and we then put a spot on that bottom line. So all we're going to do then is have our little spot on our bottom line there. And the idea being that you're going to use a couple of different pens in order to do this, so you've got a couple of different spots to look at. So that when we actually finish, what we end up with are 3 different samples. So there we go, we've got our 3 samples there. And if you really want to, using your pencil again, you can label them A, B and C. Okay, just so you remember. Now what we're then going to do with our bit of filter paper is we're going to place it into our beaker. And there's a few different ways that you could have been taught to do this. Very simple way is just to fold it over the edge of the beaker. You may have been told to attach it to a splint that sits in top of the beaker, maybe across a pencil, anything really that's just going to stop it from falling into the water completely. Now, what we need to make sure of, we've mentioned the fact that we've got some of this water, is that when we have our water and our little filter paper in the beaker, that it doesn't actually reach those spots. So when your little bit of paper is sitting in there, we don't want the water coming up above those spots or touching them. We want it just at the bottom. So realistically, we're looking at about 1 centimeter depth of water in the bottom there. So what we've got is our water in the beaker, and when we actually place our paper in, you can see it's not actually going to touch those spots. So then what we're going to do is just place our filter paper into our beaker, and we just leave it. That's quite simply how we do that one. Now the idea behind this is that we're going to watch and see what happens to those spots of ink. Now in theory what we should find is that they're going to be pulled up, that bit of filter paper, and separated out into their individual colours. Now we obviously need to leave it for a while for that to happen, but don't leave it too long so that the water doesn't go off the top of the filter paper. Okay, we need to stop it when it gets within a couple of centimetres of the top of the filter paper. So after 5 minutes, when we take our chromatography paper out, we end up with something like this. So hopefully what you can see on there is the fact that we do have these different coloured blobs that represent the different inks that we've got there. Now the key thing with this is we need to actually be able to calculate something called the RF value. Now what we need for this are a couple of measurements. The first one is the overall height of the solvent. So you can see that's where we've actually got to, okay, so where the water gets to, and put a little pencil mark on there for that. And then when we're actually measuring the spots, on your exam paper it's going to be a lot easier because they're going to give you really clear spots. But on this we'd actually be aiming for the middle of any of those particular coloured blobs. So they're the 2 values we need, and we're going to have a look at how to calculate the RF value in a moment. But from this, we can obviously see we've got 3 different pens here, because obviously we've got different colour splodges. So you've got a little red and pinky splodge there and a blue one, This one is just a pinky colour one, and then we've got a yellow and a blue on the far end. So we've got 3 different colour pens there, but we could always work out if it was the same pen, because if the actual patterns match, it's the same. So when it comes to actually working out the RF value, obviously you'd normally be doing it from your little bit of chromatography paper, but we're going to go with the easier version. So what I've done is I've created you what you'd see on the exam paper. Now what we actually have there then are the results of chromatography. So you can see what we've actually got on this side then is the distance the solvent has travelled. So it's from your pencil line to the top line where the solvent has travelled. You measure that carefully with a ruler first of all. Then whichever spot they're asking you to find, in this case we're looking at spot X over here, then we measure from our pencil line, again carefully with a ruler, to the centre of that spot. Now you can see on here that the solvent in this case has travelled 6.5 centimetres and our little spot has travelled 4.3 centimetres. Then all we need to do to work out the RF value is you do 4.3, so the distance your spot has moved, divided by the 6.5, the distance the solvent has moved. Type that into your calculator, push your equals button, and we get a value of 0.66 in this case. So that's all you need to do to calculate your RF value. The distance your spot has moved divided by the distance that the solvent has moved. And it will always be less than 1, so that's your check to make sure you've got it right. So that's our paper chromatography, but we also have another process which is called thin layer chromatography. Now thin layer chromatography works in a very similar way, but as opposed to a bit of filter paper, what we've actually got is this. Now this is actually a little plastic sheet, and onto the surface, so on this side, what it's actually got is a load of powder that's been stuck to the surface. So really fine powder of silica or alumina, depending on which one you've got, and it's all just stuck onto a shiny plastic plate. So you can see the little shine there on that side, but on this side, then it doesn't shine, okay, because that's the side with the actual powder on the surface. Now, when you're using these, first and foremost, don't go sticking your hands on the surface. You'll notice I'm only touching the very edges, so you're not going to be putting any contaminants on the surface. Now, it works very similar. We still put our little spot of our chemicals at the bottom here, usually with a capillary tube at this point. We then place it into our solvent and we let it move up. And same thing's going to happen, it's going to be dragged up the plate and then we can see the separated chemicals. The last kind of chromatography we need to know about is gas chromatography. So for gas chromatography, we get something like this. Now what we actually have is our stationary phase is in this coil here. So we've got our silica or alumina powder packed into that coil, and we've got a cylinder over here which is filled with an inert gas like nitrogen. So that's going to be our carrier, that's the mobile phase. So the carrier gas is the mobile phase and our stationary phase is the alumina or the silica powder packed in here. So what happens is we inject our substance up at the top here and it's going to be turned into a vapour. Now we then pass our carrier gas through and it's going to push our sample through this column with that powder packed in there. If we've got small particles, they're going to be able to move quite quickly through here. Bigger particles are going to move slower. So what we end up with are the different sized particles being separated and then they get picked up by the detector here, which then gives us a chromatogram on the screen of our computer. So one of the common questions they can ask us is looking at one of the multiple choice questions. So we've got an example here. Tim is separating the colours in a sample of black ink using paper chromatography. He puts a spot of black ink onto filter paper. He dips the filter paper into ethanol in a beaker. What name is given to the ethanol in this experiment? So the first thing we do is we have a look at our options and you can always eliminate something. So hopefully we know that when we're talking about any form of chromatography, the only 2 phases we've got are stationary and mobile. So straight away we can cross off A, we can cross off C, and that just leaves us with B and D, the mobile and the stationary phase. Then we think about what's happening with the ethanol. Now the ethanol is going to be moving up the filter paper. So it's moving, it's mobile, the correct answer is B. Our second question is calculating the RF value. So you'll get a set of experiment results as we can see in the diagram at the top. And what we need to do is look first of all about what it's asking us to calculate. So in this case it says look at the green spot for ink A. And you can see on the diagram that's nicely labelled for us. And then calculate the RF value for the green spot. So first thing we need to do is get our ruler and our pencil. You need to measure from the pencil line to the solvent front and from the pencil line to the centre of the green spot for A. Once you've got that, all we then do is we divide the value for our green spot for A by the solvent front, type that into our calculator and write the answer down. As always with a calculation question, do show you're working just in case something goes wrong. So what we can see here is how we actually work it out. So what we've done is we've worked out that's 2.6, we've worked out the total distance there is 5.2, and then down here we show our working. So 2.6 divided by 5.2 gives us 0.5, which we can put on the answer line. Our final question then is which ink was used to forge the signature on the cheque? Explain how you can tell. So the first thing we do is we look back at the diagram and we have a look at the ink from the cheque on the right, and then all we need to do is match those spots to the pen on the left. So if we have a little look across, we can see that those spots match with A. So you can see all three of those line up with the spots from pen A. So the answer is A forged the cheque because all of the spots actually match with pen A and the ink from the cheque. Hopefully you found our first S.O.S. useful. Obviously let me know in the comment section what you think, what's good, what's bad, what you'd like to improve, and obviously what topics you'd like to go over in the future. And don't forget to make sure you subscribe and sign up for updates so that you don't miss any of our future videos.